Harmit would be first taking today's session, followed by Sachin Kumar Sahu, another co-coordinator at Digital Wizards. So yeah, we can start.
So guys, are you able to see the screen? Hello, are you able to see the screen?
Yeah, it's visible.
Okay. So in the last session, we discussed this problem, right? Minimum swaps to sort an array. And I'll be using and continuing the same idea to show you different variations of problems which appear quite often in interviews. And okay, just before diving to the new question, I'll be just explaining the old idea that we used here to solve the problem. So we already know that we are given n elements and we need to find the minimum number of swaps to sort the array, and the elements are distinct. So the idea used here was to just convert these n distinct elements into a permutation. And we use this idea that use this theorem that every permutation can be divided into disjoint cycles. And to just explain with an example, so I'll use this example. So let's see how we can see that as a cycle. So I'll first index this array. So I'll index it like this. And now I'll find disjoint cycles in it. So 2 should be mapped to its correct position, which is at 2, right? So it should be mapped to 4. And now 4 should be mapped to its correct position, which is 4, which is 1. And now 1 should be mapped to its correct position, which is 2. So we have already found a cycle. And the other cycle would be, if I start with 6, it should be mapped to its correct position, which is 5. And now 5 should be mapped to its correct position, which is 3. And 3 should be mapped to its correct position, which is 6. So would see I have found 2 disjoint cycles. So this permutation could be written as 2, 4, 1 as one cycle and 6, 3, 5 as another cycle. Now what benefit this gave us was that my minimum number of swaps, so if I have to sort this cycle, which is 2, 4, 1, right? So let's try to sort this cycle using swaps. So I can use one swap to just do this, right? So 4 to 1, so 2 is placed at its correct position. And now I'll use another swap, so which should be 1, 2, 4. And you can see here that I have kind of, saved one position here. I have used only 2 swaps. However, the number of elements were 3, right? So the other swap was this one. So I have saved 1 swaps on each cycle. So the minimum number of swaps would be total number of elements, or let's say that it's n minus the number of cycles. right? And yeah, this number of cycles could be interpreted as, okay, this number of cycles could be interpreted as the number of moves, the number of swaps saved per operation. So number of swaps saved per cycle, right? So that was the approach we followed, and let me just quickly go through the code also. And this thing was just to convert it into a permutation. So uh, could somebody tell me what was the time complexity for this operation? I just converted that array into a permutation. So okay, that time complexity for this is n log n, because I'm just sorting the permutation based on some operation, right? So okay, if even if you don't understand that, it's sufficient, because the whole idea here is to just convert that array into permutation, and that the step involves of n log n time complexity. And now the main thing is, this is the algorithm for finding the cycle. So I'm just going to explain this algorithm. So okay, how should I find, okay, there is a cycle, and how should I identify the number of cycles? So for the algorithm, so the algorithm for that is, so I'll just go to 2, then I'll check the position of 2, which is array of 2, right, which is equals to 4, right? Now I'm going to go to array of 4, which should be equal to 1, and then I'm going to go array of 1, which is equals to 2, right? So I'll maintain a visited variable here. So once I visit a number, I'll mark it as visited. So I'll mark it as 1. And now once I jump to its correct position, which is array of 2, I'll again have a variable which will mark that, okay, this position is also marked as 1. And then I'll again mark it as 1, and again 1. Now once I find, okay, this is a number which is already marked as 1, then I found my cycle. So that was the algorithm that we used to find the cycles. So I'll just explain it. So I'm just maintaining a visited array, and so while it is not visited, I'm going to visit that position, and I'm gonna go to the next position based on that, the correct position, and I'm gonna repeat it. Once I've found, I'm just going to increment my number of cycles. And if it is already visited, then I'm just going to continue. And at the last, I'm just returning n minus number of cycles. So the idea here was to maintain a visited array, but notice that we are not doing anything with the array itself. We are just maintaining a visited array, and the idea here is to just count the number of cycles. Now let's look at the motive of this session, which is this question. So given n distinct elements from 1 to n, so just look at n distinct elements are there, and the range is from 1 to n, and we need to sort the array in O of n time and O of 1 space. So okay, can somebody tell me why, okay, what is the naive way to sort an array? Like, what is the time complexity the best possible time complexity to sort any generic array? Hello?
Guys, any answer to that?
Is anyone, at least someone from computer science?
N log n?
Yeah, that's correct.
Who's
So
that?
n log n is the time complexity to sort any generic array. All right, so you know that n log n is the time that is needed to sort any generic array. But now this is not a generic array. And how can we say that? First of all, we have n distinct elements and the range is fixed, right? So that gives us an opportunity to just look at okay, that there is a possibility of reducing the time complexity. So we have some additional constraints on the array. Okay, now let me just explain the algorithm involved here. And okay, like one more thing is that only allowed operation is swapping. That seems very trivial because if you have all possible operations, then you could just, then you don't have to sort it. Then you already know that my answer is 1 to n. So let me dive into the solution. And the idea here is the same idea that we discussed earlier. It is the same idea that we have used here. And we are going to use this term that every permutation can be divided into distant cycles. And okay, let me explain the algorithm. So we have 2, 4, 6, 1, 3, 5. And let me mark down the indices. And I'm just going to start with 2. And I'm going to see the correct position of 2, which is here, right? So I'm going to compare both these numbers. I'm directly going to swap both these numbers. So I'm just going to do 4, 2, 6, 1, 3, 5. And now I'm again going to stay at this position and I'm going to see the correct position, which is 4. And again, I'm going to swap both these numbers. And now you can see my 1 is already fixed, so I don't have to swap. Even if I swapped it, like it would be like a loop. So I don't have to swap it. Similarly, 2, I don't have to swap it. And now let's look at 6. So 6 should be swapped with 5. And now I'm going to stay at 5 only, and I'm going to swap it with its correct position, which is 3. So my 3 is also fixed, and my 4 is also fixed. 5 is also fixed, and everybody is fixed. So I have sorted the array. Now I want you to focus. Okay, what is the similarity between the previous algorithm and this algorithm? Here we are just simulating the same idea that we have discussed here. Like I'm iterating here, we iterated over the cycle. But here we are directly swapping it. Like we are performing the swap operations directly. So here we said, okay, we'll be finding the cycle first and then we'll be rearranging the cycle. But here we are just doing it on the fly only. So you can see the numbers that I swapped with 2, like at this position was 2, 4, and 1. And these are part of this cycle 2, 4, and 1, right? This cycle. And the other thing that we swapped was these 3 numbers, 6, 5, and 3, right? And these numbers are part of another cycle. So here we maintained a visited array, but here just look at it. We don't have to add any declare any extra array and modify it and you know work through a solution. But here we have used the same array. We have sorted the array, and we haven't declared anything extra. So this is done in of n time, and of one space. And now there might be some doubts. Okay, why this is off in time? Like I'm doing some extra operations here. But just think about it. Whenever the main idea here is whenever I'm applying an operation on a number, say I, then after applying the swap operation, I'm very sure that my number would be placed at its correct position. So it will be placed at the correct position. So even if I encounter it later, I won't be applying any operation on it, right? So at max, the number of times we'll be encountering the same number is 2. So the time complexity would be 2 star n, which is order of n. And okay, like even if you didn't understand this algorithm, I'll be explaining it through code. And okay, but before that, let's look at a few problems. So before that, if you guys have any doubt in this algorithm, just say it, I'll explain it again. Guys, any doubts? So
Any queries? We have something.
okay, so if you don't have any queries, let's look at one of the problems.
We have one query. Just check the messages.
Why we start doing sort if we know number is from 1 to n? Yeah. That's exactly what I discussed here was. Okay, just a minute. So you can see that like the only allowed operation is swapping of 2 elements, right? So I discussed it like the only allowed operation is swapping of 2 elements. So you have to kind of change. You cannot change the elements inside array. So if you have 2, 6, 1, 3, 5, then or yeah, and then you cannot say that I'll be changing 2 to 1 and 6 to 2 and 1 to 3, 3 to 4, 5 to 5 and 4 to 6. So I'm not allowed to do any kind of these operations. So only allowed operation is swapping. Otherwise, this problem was yeah. Right. I hope that is resolved. Okay, so let's look at a lead code problem. So not sure if you guys are able to see the problem. So we are given an array of integers, nums, containing n plus 1 integers, where each integer is in the range 1 to n inclusive, and there is only one repeated number in nums. Return this repeated number. So let me explain the solution, the question. So let's explain it with an example. So you're given an array. Let me take the same array. And now what the problem says is that I have a repeated number. So let's say 3 is repeated, so this will become this. So I need to return this repeated number, and the constraints are 1 to n. The constraints are like 1 to n. So any ideas how to solve this problem?
Can you show the question again once?
Yeah.
So as only one number is repeating, we could find the sum of the entire array and subtract it from
Yeah.
subtract n into n plus 1 by 2. Like
Yeah,
the sum
that's
of 1 plus
yeah.
2.
We
Yeah,
can
you could
also do
follow
like
the
Be
same.
overflow time. It will be done overflow time.
Yeah, you could solve it using the same method, but uh, like if I want to use it using cyclic sort.
I think we should go in the cycle from the starting point, but at some point, if we again encounter some visited number, but which is not the starting point, then we know that it is the repeated.
Yeah. So okay, but as you will be maintaining a visited array, the time complexity will increase. Sorry, the space complexity will increase. So if I want, if I don't want to declare an extra array,
we can simply XOR the elements and XOR with 1 to n also. It will give
yeah,
the result.
we can use that approach, but is there? I want a solution which is I want the solution using cyclic sort. The reason why I'm telling you this is because I'll be discussing another problem, and there, like these kind of techniques won't be applicable.
If we like go through the array and say I'm at 1 uh, and then like I'm finding the correct position for 1, and if there is
Yeah.
already a 1 at the correct position, then that is the repeated number.
Yeah. Okay, so you are a little bit close. Yeah, I think your idea is good enough. So, okay, so let me use cyclic sort here. So, okay, so what cyclic sort does is, so given any array, it will any permutation, it will just sort it. So, but the key idea that cyclic sort uses here is that if I have a number, then it is mapped to its index, right? So 3 would be mapped to 3, right? So if I just try to apply cyclic sort here, like 2, 4, 6, 3, 3, 5, then I know that, okay, my 2 would be mapped to its correct position, which is here, right? So my 2 is mapped to its correct position. Similarly, if I apply on 6, it would be mapped to its correct position. Similarly, 5 would be mapped to its correct position. But when it comes to 3, 1, 3 would be mapped to its correct position, but we don't know like where the other 3 goes, right? So if you just look at this problem, we are given n plus 1 integers. So if I have this, okay, so 2, 4, 6, 3, 3, 5, then the index should be 1, 2, 3, 4, 5, 6, right? So I know my 2 would be mapped to its correct position, 4 would be mapped to its correct position after applying cyclic sort, 6 would be mapped to its correct position, 5 would be mapped to its correct position, 1, 3 would be mapped to its correct position. But you know, like the algorithm is something like this. So once I've placed my number at the correct position, so 3 is placed at the correct position, then I'm just gonna ignore it like it is already placed. So this 3 would be stuck at some different position, right? So guys, any doubts? Okay, let me just brief over the idea again. So here our main idea was not to just sort the array, but the implementation here goes something like this. So the idea is that I want to place now my goal is to place 2 at its correct position. 2 at its correct position. Correct position. And okay, I'm able to do that. So yeah, 2 is placed at its correct position. Now I'm going to 4. 4 is placed at its correct position. 6 is placed at its correct position. 3 is placed at its correct position. And if I already know that it is placed at the correct position, then I'm just skipping it. So the first 3 that I encounter in a cycle, that would be placed to its correct position. And the other 3, I don't care where it goes, but I'm just gonna ignore it. So in this case, it would be placed at 4, not 4, but yeah. So that's the whole idea. Okay, let me just try to code it and you will understand that better. So let's see, we have numbers. So let me first find the size of the nums. Now I'm just going to use a for loop. Now let me just ignore this. And now I'm just going to apply the normal cycle sort algorithm. And the correct position for the element would be, like in this case, the correct position for 3 would be at the index 3 minus 2, which would be 2. Right? It should be nums of 3 and if my nums of 5 equals nums of, it's not equals to, right? So what this line is saying is, if my number is not placed at its correct position, so here 1 is placed at its correct position, we can just ignore it, and 3 is not placed at its correct position, so we are going to find the correct position and swap it. So this now the control enters here, so we'll swap. And yeah, here one more thing is that here the indexing is from 0. So this array would be like 0, 1, 2, 3. So if I'm going to check 1, it's at the correct position. it is same as saying if it is at array of 0, if it is at index 0 of the array. So I'm going to use that, and now I'm just going to swap. Else I'm going to increment the index. So that's what I did, right? If my index was not, if my element was not at the correct index, then I'm going to swap it with whatever the number was there. Otherwise, if it is already at the correct index, I'm just going to go to the next number. So I did this. And now I'm just going to find which of the numbers is not placed at its correct position. So I'm just going to iterate over it. And if my nums of I not equals to I plus 1, then I'm just going to return nums of I. Let's do a quick walkthrough of the code. So I have just calculated the size of the array. I have just iterated over the array. And now I'm finding the correct position of that array. So 1 should be mapped to 0th index, and 3 should be mapped to second index, 4 should be mapped to third index, and 2 should be mapped to first index of the array, because the array is indexed from 0. So I found out the correct position. And once I found that it is not placed at its correct position, then I'm just going to swap it with that number. Otherwise, I'm just incrementing my I. So let's try to run this code. Okay. We need to add some extra number here. Let's try to return any number. So let's try to submit it. So, it is accepted. So if you guys have any doubt in this implementation, I could explain it once again. Or if you want me to explain it using an example here, then I can also explain it if you want. So okay, guys, if you don't have any doubts, let's move on to the next question. And yeah, so we have this question. So, okay. So the question is very simple. Given an unsorted array, and we need to return the smallest missing positive integer. So any ideas about how to solve this problem? Okay, any idea? I don't want of an approach of constant space. So any idea? Okay, so guys, I'm going to ask you a question here. Okay, so if I'm given n integers, so let me clear this first. Or let's just write it here. So if I'm given n integers, like in the question itself it is stated, and I need to find the first missing positive. So first missing positive. I want you guys to tell me what is the range for this. Like, okay, like it could be 1, it could be 2, it could be 3, it could be, tell how much. I want this number. Just think about it. So, okay, when could be 1 the first missing positive? When the array has only negative numbers or non-negative numbers, or something like this. So here the first missing positive would be 1. So when could 2 be? It could be like my number has some negative numbers and 0 is there, 1 is there, and some other number is there. And I want you to tell me what could be the maximum range for this. Okay, let me just say this. So I have a claim. Let's call this x. So my x should be less than equals to n plus 1. So do you guys agree or see why this is true? Okay, let's prove it using contradiction. So let's say my first missing positive is n plus 2. Then this would mean that all the numbers from 1 till n plus 1 are already present in the array. But the size here would become n plus 1, which is not possible. So that's why a missing positive should be less than equals to n plus 1. So guys, any guesses or any doubts? Okay, so since a missing positive number should be in, so this inherently speaks like to 3 till n plus 1. So this is my range. This is my range for the missing positive. Okay, now do you see what is this? This is a permutation, right? This is a permutation. So I found out the range for x and I said, okay, this is a permutation. Now I want to say what is my first missing positive number. So do you recall that we have just discussed cyclic sort here? What was the idea behind it? Okay, let me just, I'm not getting, let me work through an example. So 3, 4 minus 1. So suppose I want to find the first missing positive in this array. Then I can apply cyclic sort here, but I'll just modify it a little, like cyclic sort. And I'll say, okay, and this is the index of the array, like it should be 1, 2, 3, and 4. So I'm just going to say, I'm just going to start with 1. I'm going to start with all these ranges that x could take, all the values that x could take. So I'm just going to say map 1 to its correct position. So I was able to map 1 to its correct position. Okay. Now, okay, in the second, I don't have any candidate. So I'll just go on to the next thing. so which is 3. So 3 could be mapped to its correct position, 4 could be mapped to its correct position, -1 is left, and it would be placed here. So now I'll just iterate here and I'll find the first number which violates this principle that my element is not equals to its index. So the idea is, if I have some array, then I'll just try to map all elements starting from 1. So first I'll say, okay, trying to place 9 into its correct position. So if my 9 is greater than equal to n plus 1, or greater than n plus 1, or greater than equal to n plus 1, then I cannot map it. The reason is because I have the array size of n elements only, right? So I cannot place 9 to, n here, like n plus 1, right? So I'll just skip this number, right? So in this case, it won't be skipped, but if I have 19 here, then it would definitely be skipped. So if it was 1, 2, 3, 4, 6, so the numbers here are 1, 2, 3, 4, 5, 6, 7, 8, 8. So 19, there is no index where it could be placed. I'm just going to ignore it. 8, I'm going to place it here. 1, I'm going to place it here. 3, I'm going to place it here. 4, I'm going to place it here. 2, I'm going to place it here. 6, I'm going to place it here, and okay, there is one more element. Okay, this should be, let's say it is some other element, just 14. It is again out of range, so I won't be placing it anywhere. So both these numbers won't be swapped. So they would be already be at the position they are designated to. So 19 could be here, or 14 could be here, or 19 could be here, or 14 could be. So we don't know. Now we'll just iterate over the array, and where we find the first violation, we'll say, okay, this is the position which is the first missing positive. So even if I had like a negative number like -9, then I'll say this number is could not be mapped because it is not in this range, right? Since it is not in this range, so we cannot map this number. So that was the general idea. Okay, even if you didn't get it, I'll try to explain it in the code. So my first step would be to calculate the size of the array. And now I'll be using a for loop. Just the same way we did with the previous example. Now, if my nums of I is greater than equal to 1 and nums of I is less than equal to n, this states that it is in range. Then I'm going to check if my okay, I won't be checking, so I'll be declaring the correct position. It should be nums of I minus 1. And then if my nums of is not equal to nums of nums of I. And otherwise I'll be just incrementing. If they're same, then I'll be just incrementing. And if they are like not in the range, I am not going to do anything. I'm just going to the next number. So that is the thing. And now I'll simply run a for loop. And if my nums of I is not equals to I plus 1, then I'm going to return I plus 1. So I plus 1 is used because the indexing is 0 based. So my number 1 should be placed at 0th index. So I will be returning I plus 1. So, and if my whole array is exhausted, then I know that the case is something like I have all the numbers from 1 to n. So I'll be just returning I plus 1 as the first missing positive. So just a recap. I knew that my answer is my first missing positive has to be less than or equal to n plus 1. So I'm just going to focus on only on my answers, the values that my first missing positive could take. So I just start by mapping all the values which are in this range 1 to n to their correct positions. And once I have done that, I'll just iterate to check which of the elements is not at the correct position, which is the first element which is not placed at the correct position, and that would be my first missing positive number. So you see the code for them is almost same, right? But here we just need to find that, okay, my answer is less than or equal to n plus 1. And okay, let's try to submit it. So it is accepted. Yeah. So that was all about cyclic sort. And guys, like these questions come a lot in interviews. This is one of the most popular interview questions. Find the duplicate number. And yeah. So if you have any doubts or you want to explain any topic again, I can explain. And the thing is that for cyclic sort, you won't be able to find a lot of articles or questions online. So, and this topic is somewhat important. So, if you guys have any doubt, you could tell me. Okay, if you guys don't have any doubts, we will be jumping on to divide and conquer. So we'll be starting with merge sort. So merge sort, I think many of you might already know it, but here the intention is not to just say, okay, I want to sort an array, but it's kind of explaining another concept to you, which is counting inversions in an array. So it is regarding the last problem that we solved in the last session, and I just gave an O of n square solution. So it is the same problem here, and we just gave an O of n square solution, and we discussed like can we come up with a better algorithm, and we said, okay, this could be done in n log n time complexity, but let's see how we can do this. So before that, I'll be first explaining you the merge sort algorithm. So merge sort algorithm, the basic idea here is So divide the array into two equal parts. Sort both the arrays. Sort. And merge them. So what we are here doing is, okay, we are dividing this set, 2, 6, 5, 8 as one array. We are taking this as one array and this as another array, and we are trying to divide it as much as we can until we get an array which is already sorted, and the size is 1 because a single element is always sorted. And then we are using this fact that my algorithm will give us. So here in recursion, you have to understand that when I'm defining my recursive solution, I have to assume that my answer is already correct, which means that if I'm at this step, I'll be assuming that I'm getting sorted arrays. As you can see, here we are getting sorted arrays, and here also the inputs are fed as sorted arrays, and that's the whole idea. So let me try to explain you with the code, and that would be better. So here we have an array, and let me try to write a merge sort algorithm for this. So we can have a function called void merge sort, and it will take in array as input and left and right. And what it returns is, it returns, or you can say sorts A between left and right included. And so what it does is, it has 3 steps. So as I told you, first it will be assuming that we have already sorted half of the array. So we'll be defining a mid. It should be left plus right minus left. By 2. So it will be assuming that we have already sorted the portions from left till mid and mid plus 1 till right. So it says that, okay, the definition was it sorts A between left and right included. So what it will do is, it will sort A between left and mid, and this will sort A between mid plus 1 and right. And now we'll have another function called merge, which will merge both these arrays. So merge A from left till right. And that's the completion of this function. And yeah, the base case would be, if my left equals right, then return, because I already have a sorted array. Right? So I'm sorting the array from left till mid, and then I'm again sorting the array from mid plus 1 to right, and I'm just merging 2 sorted arrays. So now we have this problem of implementing this merge function, which is merging 2 sorted arrays. So let's try to implement it. Now the idea here is, let's say we have an array, let's say 2, 5, 6, 8, and minus 1, 0, 7, 11. So we have two sorted arrays and we need to merge them. That was the thing that it was saying. So how could we sort them? Let's see. So I'll be maintaining two pointers here. So both the pointers would be initially pointing at the start. So I'll first compare both the numbers at the pointer. So 2 and minus 1 would be compared and they would be added in this. So the result, okay, this one. So I'll be comparing both these numbers and whichever number is smaller, I'll be inserting into a new array, which would be, let's call it temporary array. Okay, so minus 1 is already placed at the correct position at in this array temp. And now I'll be incrementing this pointer. So this pointer would now be at 0. So I'll be again comparing both these numbers and whichever is smaller, I'll be placing it here. And okay, I'll be again moving this pointer to 7. Now I see, okay, 2 is smaller than 7. So I'll be placing 2 here. And now I'll be incrementing this pointer to 5. And now I'll be comparing 5 and 7. So 5 is smaller, then I'll be placing it here. And now I'll be again incrementing my pointer to 6. Now I'll again be comparing 6 and 7. It should be 6, which is smaller. So it would be placed here. So once I, fill it, then I'll be moving my pointer to 8. And now 7 would be placed here. And now this pointer would be placed here. And between these, 8 is smaller, so it should be placed here. And finally 11 is there. So that's how I'm going to merge these sorted arrays into one single array. And now these arrays are part of A only, right? It is from A to mid, and it should be from mid plus 1 to j. Or let's call it left and right. Left and right. So, and this temp is something which is independent of A. So we need to refill these positions, the sorted positions from left till right. So what we are simply going to do is, so this index is like 0, 1, 2, 3, and our array A's index is from left till right, right? So I'm going to say this should be placed here. So I'll be placing temp of I plus left. So my A of just a minute. Just neatly write it down. So I'll be placing A of I equals temp of I minus left, where I goes from left to right. So temp of 0 would be placed in A of 0. A of left. A of left would be equals to temp of 0. And it will go on. So let me try to implement it. So let's declare the mid first. So mid equals left plus right plus right means left. And a temporary array, which should be right minus left plus 1, because left and right are included. So left minus right minus left plus 1 will give us the total number of elements. And I'll be initializing I to left, the pointer here. So this is the pointer which should be initialized to left, and the other pointer should be initialized to mid plus 1. So they should be initialized to mid plus 1, and I'll have another pointer k which should be used for filling out a temporary array, which should be initialized to 0. And now I'll be using while I is less than equal to mid. So this is the condition for this, like my I pointer should be less than mid, and the other pointer should be less than right, less than equal to right, and less than equal to mid. Yeah. And now if my ref I is greater than ref j, this means that I need to place array of j in my temporary array. So temp of k equals array of j. And now I'll be incrementing k and j, because I've just filled k and I have just gotten over with a of j. Else my temporary k would have a of j, a of I. And now once I have filled this thing, I might have some cases like, okay, my I has just gotten over, like something like I have some numbers like 1, 2, and something like 3, 4, 5, 6. Then I'll be filling 1 there, 2 there. So my I would already become mid, and the while loop will break. And I won't be able to fill these positions in temp. I need some extra logic there. So let's try to see that logic. So while temp of a plus plus equals a of I plus plus, and there's the same logic there also. A is less than right, less than equal to right. So this condition would be encountered in case our j gets over first. So I'll be just filling the remaining entries with I. And here, in case my I gets over first, then I'll be filling the remaining entries, starting with index j till right. So that's the whole code. And let's try to run it. So let me just call merge sort here. Should give the sorted in. Merge. Okay. P comma 0 comma. Oh, sorry. Yeah, there is one more step which is missing here. Is that I need to that last step that I want to equate it. So this should be right minus left plus 1. And my array of I plus left should be temp of I. So I'm just copying the values in the sorted array, which is temp to A. Yeah. So that sorts array. And yeah, that's all about merge sort. And here's a slight modification that I want you to see is this problem, count inversions. So I hope you have already read that problem in the previous session. So we just want to count the number of inversions in an array. So let's take this example 2, 4, 1, 3, 5. So clearly 2 is greater than 1. So that counts for 1 inversion. 4 is greater than 1 and 3. So that counts for 2 more inversions. And rest everything, there are no inversions. So the count of inversions is 3. Okay, now we discussed O of n square solution for this. And if I want to optimize it to O of n log n, I'll use merge sort. How? Let's see. So I'll be using this approach. So given an array, I'll find the inversions from 0 till mid and then mid till n. So if I have the inversion count for these things, and I have this array sorted like 2, 3, 4, 5, 6, and 7, 8, 9, 10, then I know that the total number of inversions would be inversions found in the left portion and inversions plus inversions found in the right portion plus the inversions done via merging both these, right? The inversions from 0 till mid and from mid till end, and the number of inversions which we will get by merging these. So these are the total number of inversions. And okay, why should this give us the total number of inversions? The reason is that once I have done this operation, I'll get a sorted array. So 2, 3, 4, 5, 6, 7, 8, 9. And I know that this doesn't have any inversion. So this has 0 inversions. So whatever inversions I have calculated, that would be caused either through this portion or through this portion or by merging. So that's the whole idea behind this. And let's try to implement it. So I have this merge sort. I'm just going to modify it a little for this problem. So now my merge sort will give me the inversion count. So I'll make it return type int, and I'll initialize my inversion. So if my left is equals to right, we have only a single element, and the inversion for that should be 0. And I'll initialize my inversion to 0. And now my total number of inversions would be inversions found in the left portions plus inversion found in the right portion plus inversions due to merging. And I'm going to simply return the inversions. And okay, now what should be the inversions which we via merging? So let's look at that. So we have some array 2, 9, 11, minus 1, 11, 13, or 9 and then 13. We have these two arrays. What should be the inversions that we encounter via merging? So if I have 2 here and I found, okay, 2 is greater than an element. Okay, let's not take 2. Let's take 9 for example, or let's make it 10. So if I'm at 10 and during my merging step, like the 2-pointer thing that we applied, if I encounter, okay, I'm comparing these two numbers, then my inversion count for this thing would be, so clearly 10 is greater than 9. So all the numbers which are greater than 10 would also be greater than 9, right? All the numbers which are greater than 10 would always be greater than 9. So my answer would also, so while traversing this array, I'm just going to do this. My answer inversion plus equals to, this is mid. So mid minus, let's say this is index is I, mid minus I plus 1. Because all numbers from here to here would be greater than this number. So they will be incrementing the inversion count by this amount, right? So I'm just going to use that idea. So if my AI is greater than AJ, I'm going to increment my inversion count. So inversion plus equals to, so let me just declare inversion here. Either. Inversion plus equals to mid minus I plus 1. And at the last, I'm just going to return the number of inversions. So our merge should return the number of inversions. Yeah, that's it. Let's try to print the inversion. So it gives us 3. So yeah, that's the example we tried here. It gives us 3. This example, right? So I'm just going to copy paste this solution there. And yeah, so this is in long, so I'll be converting everything to long here. And here our answer would be just that sort of. Yeah, so let's try to submit it. Yeah, so that works. So yeah, that's it from my side, guys. If you have any doubts, you could ask me. Yeah. So
Yeah, guys. So that was Hermit's part. If you guys have any queries, you can ask him right now itself, or you can just post a question on Discord server. We'll be more than happy to help you out. Next up, we have Sachin. Sachin, are you there?
Yes, I'm here. You can hear me, right?
Yeah. Yeah. You're audible. So Sachin will be taking the next part of the session. So I hope. Let's see. Yeah, Sachin, continue.
Okay. Thank you, Soham. So since we don't have much time, so I'll be quick. So let me share my screen first. Okay, so I'll be starting with sieve of eratherasis. So I hope you must be knowing about prime numbers. So give you a glimpse what prime numbers are. Prime numbers are natural numbers which have factor as 1 and the number itself. So the method which I'm going to tell you is a fast method which helps you to find the list of prime numbers. So suppose the question says you have to find prime numbers till n. N can be any large number, suppose 1000 or 2000. So you will have to find that. So how it will help, I'll show you now. So you must be knowing about sieve. What is a sieve? It will allow some particles to pass through. So using the same idea, what we'll do is, see, we have a list of numbers. Suppose question gave you to find numbers, prime numbers from 1 to 100. So you will have to make a grid from 1 to 100. And so I'll show you the step. First of all, you must be knowing that 1 is not a prime number. 1 is neither prime nor composite, whereas 2 is a prime number. So since 1 is not a prime, so you cross it out first of all. Now just check that 2 is a prime number. So this method says that since 2 is a prime number, so every multiple of 2, you will have to cross it out. So since 2, we are considering 2 right now, so every multiple of 2 has been crossed out. And crossed out means that these numbers which are crossed out won't be prime numbers. So we'll just ignore them and we'll be focusing on other numbers. So for 2, we did this step. We'll repeat this step for 3. Now check that the multiples of 3, that is 9, 15, 27, etc. All these have been crossed out. And the only things which we will consider from now onwards are the numbers which are not crossed, which are yellow in color. We'll repeat this for multiple steps. So see, we showed only for 3. Similarly, you will do for 5. For 5, you will cross out 25, 35, and all those. Similarly, for 7, you will cross out other things. And finally, you will get all the list of prime numbers. The non-crossed number will be the prime numbers. So you will get 3, 5, 2, 3, 5, 7, 11, 13, etc. And all these numbers are prime numbers. So this is a simple theorem which helps you find list of prime numbers. I'll briefly show you the code. I would recommend you to check it out like by yourself, because it might be a bit tricky to follow. So here is the code. So first of all, you make a vector of bool, that is just like we made an grid there. We make a boolean vector which is from 1 to n. We are assuming n plus 1 because of some indexing. And here is prime is a boolean variable which will show you whether this current number is a prime or not. So you initialize that 0 is not prime. 1 is not a prime. And now we run a loop from I equals to 2 to I from 2 under root n. And here is an optimization. You're running till under root n because you have factorization. If you check from more than root n, you won't get anything. That's why it is an optimization. I'll recommend you to check out after this session and you will get the clarity. So you run a loop from I equals to 2 to under root n, and every time you check if the current number is prime, uh, so what you'll do, you'll check all its multiples. See, you're starting from twice of I and till n, and every time you're increasing I, j plus equals to I. So suppose I was 2. So since I 2 was a prime number, so this loop will run, and what it will do, it will do for 4, then 6, then 8, then 10. Every time you will increase 2. So all those numbers will mark prime equals to 0. Since 2 was a prime, so 4 won't be a prime, 6 won't be prime, 8 won't be prime. So that's why this internal loop will cross out all the multiples. So this single loop will cross out all the multiples, hence the numbers which are not prime will, their boolean will become 0. And finally, what are we are doing, we are iterating over the whole grid, the 2D grid, and we are just checking if number was a prime, you push it in the answer, and finally you return the answer. So don't worry about the implementation, but the idea which I told you about this grid, you should keep this in mind. Every multiple you cross it out, and remaining will be your answer. So this is a very important theorem to find prime numbers, because every time whenever you want n prime number, you just check it this from this, you will get in O of 1. So just keep this in mind. It might not be easily, like you might not be able to realize this right now, but in future you will see implementations and requirements. So just keep this in mind. Any doubts? I'll take the next question then. This is 2 pointers. Question from 2 pointers. Okay, so just read. Okay, let's go through the question once. This is a lead code question, and what we have here is we have a 0 indexed integer array, and it's of even length. We have equal number of positive and negative integers. So here we have this array. We have 3 positive numbers and 3 negative numbers. Okay. So we are asked to rearrange it such that every consecutive pair has opposite signs. And the order of positives and order of negatives is preserved. Okay, let's see example. I'll explain you. So this was the input. We have 3 positive numbers, 3 negative numbers, and the output is every consecutive pair is alternate signed. And the size of positives like 3, 1, and 2, this order should be preserved. 3, 1, and 2. So we have the order preserved. Similarly, for negatives, -2, -5, -4, we have the order preserved. Okay, hope you got the question. Any ideas? If anyone would like to share their idea, please let us know fast. Else I'll start with the explanation.
Okay, so we'll have two variables, 2 pointers, one for the positives and one for the negatives, and whenever we encounter one, we put it in the position and increment the number by 2. For example, if we start at 3, 3 will be placed at index 0, and then we increment it by 2. So we go to the index 2, and then we encounter 1, right? So 1 is placed in index 2 position. Then for negative numbers, we'll be having another pointer, which will start at 1 this time, or it will start at 0 based on the first number.
Right, good observation.
What's your name?
What's your name?
Chandraditya. of Chandra.
Okay. Okay, very good observation, Chandra. So we'll proceed with that solution. So see, the question was, it might have been looking a bit difficult, but solution is very easy. So I'll explain briefly what Chandra was saying. Uh, so you had this input element. You make a new vector, which will be the answer element. Will be answer vector. We'll return this. Now what we do, we have an positive index. We have negative index. Positive you mark as 0, negative as 1. It's you can do reverse also, it's okay. Now you iterate through the nums array, and now you check if the number is positive. You push it to the positive index, insert it in the positive index of answer, and increase it by 2. If this number was not positive, that means it was negative, so you push it to the negative index and increase the negative index by 2. Chandra, is this the same idea which you were telling?
Yeah, that's the one. Yeah.
Okay, perfect. So, like, is it clear? The point clear? See, we have positive index. We are increasing it by 2. Why? Because we need positive numbers and then negative numbers. So suppose pi was 0. So next positive number is after 2. So it was 0, then it should be 2. After that, it should be 4. So positive index, you should do +2 every time. Similarly, for negative index, it was from 1, then it is 3, then 5. So just iterating once, you got positive and negative numbers alternate. Idea is very simple. It's 2 pointers, 1 pointer for positives, 1 pointer for negatives. If you guys have any confusion, please ask. Okay, is it clear? Okay, I'm assuming that it was clear because it was not difficult. It's just kind of alternating the. You just have to understand the question and that's it. Okay, I'll take this one more question. So this question is based on sliding window. Okay, let's read the question once. So question is minimum size subarray sum. Don't worry, it's not too difficult to understand. So we have an array of positives and you are given a target and you need to find the minimum length subarray whose sum is greater than or equal to target. You need to find minimum length subarray. Question deals with subarrays. And to give a clarity about subarray is a continuous part of the array. That is, if you consume this array, so this selected portion is a subarray. This selected portion is also a subarray. Any continuous part is a subarray. It should be continuous. That is the condition. So you need to find minimum length of this subarray and elements. If you sum up the elements, it should be greater than equals to the target. Okay. Okay. So you have this positive integer nums and this target you are given. Okay, now here let's check this one. If you take a subarray and sum it up, suppose I choose this. What is the summation? 3 plus 2 plus 1, 6. It is not greater than equals to 7. So you will change it again. Let's check some other part. So you have 1, 2 and 4. Summation is again 6. It is not greater than 7. If you check 4 and 3, the summation is 7. So it is greater than equals to target. We might choose this one. 7 plus 2, 9. It is again greater than 7. But we are missing the condition that the length should be minimum because this length was 3 and we have another possible solution with length 2 whose sum is greater than equals to 7. Hence we got this answer. Take example 2 again. We have this array of size 3, we need target 4. Target given is 4. If I just choose 1 and 4, sum is 5 greater than equals to 4. But one solution that is choosing only 4 and it's greater than equals to target, it satisfies the solution. The given condition is satisfied and output is 1. 1 is the length. Here length was 2, so output was 2. Now check this. This is another edge case. You have the array, but even if you sum everything up, you won't get the sum greater than equals to 11. So you don't have any possible subarray, hence output is 0. Are you guys okay with the problem? And anyone would like to suggest any solution? Any brief idea? It's fine. Is the question clear? Okay. Not sure if you guys understood this or not. Okay, I'll brief it once more. So we have input array, we have positive integer target. You need to find the minimum length of subarray. You check any subarray, you need to minimize the size of subarray such that summation of those elements is greater than or equals to target. Okay, how about if you choose any brute force, if you follow any brute force, what can be the brute force approach?
Just going over all subarrays of n square time, and then we could compute each sum.
Yes, right. Choosing all kind of possible subarrays, like size of 1, size of 2, and summing up and checking if it's greater than equals to 7. So that is an O of n square. It's not O of n square, I think, because when you will sum it up, it might go of n cube. But assume it's not optimal. It's obviously it's not optimal. So one point, if you observe, is that subarray is a continuous segment of array. So this gives you an hint that if we just consider the starting and ending point, we just need to focus on start point and end point, and that would give us the subarray. And last step would be to sum it up and check the condition. So generally, the pattern which I have observed is as if question talks about subarray or something similar to continuous thing. So generally, idea of sliding window works, and that is what we'll do it here. And sliding window will help you get the answer in O of n. Okay, so check this out what I wrote. So we'll maintain 2 pointers, left and right. And since the condition says that the sum between those pointers, if it becomes greater than equals to target, so we'll increase the left pointer. Okay. If target sum becomes greater than equals to, then you'll increase left pointer, and we'll keep on checking if another length of window exists whose sum is greater than equals to the target. And why are we doing so? Because right pointer you can always increase, but you should have a condition, like you should be knowing when to increase the left pointer. And left pointer will increase left pointer when internal sum becomes greater than equals to target. What increasing the left pointer means is that the left pointer you'll increase, that means the size, the length of subarray will decrease, and it's obvious that the sum will also decrease. So whenever you get this condition, you can remove the left element from consideration. You remove the left element from summation and check the remaining sum if it matches the condition. And each time when the summation is greater than, like this condition is satisfied, you check the length. And every time you store the minimum possible length you got. Okay, check this. Left pointer, right pointer. Suppose it's here. The sum is 5, 8. Sum is 8. It's greater than 7. So what I want to say is that since the summation of this part is 8, so I can remove the leftmost element and keep only this part. That means I remove 2. So sum now is 6, but it's not as satisfied. When condition is not satisfied, you increase the right pointer like this. Now you check the sum again. Sum is 10. It is greater than 7. That means you can remove the left pointer. You can remove 3. So left pointer at 1, right pointer at 4. Sum is 7. When the sum is greater, you have to check the length. Is it clear? It might be a bit confusing, but idea is only just keeping left and right pointers. Left pointer and right pointer and sum the internal stuff. And when sum of internal stuff is greater than 7, that means you can remove the leftmost element. And it is kind of intuitive because you are kind of shifting the pointers. Right pointer, if you increase the right pointer, that is if it was at 4, you increased it, so you are increasing the sum. If you remove the leftmost element, you are kind of decreasing the sum. So this is what sliding means. Sliding the right pointer to add more elements and sliding left pointer to decrease elements. And operation is summing up the internal stuff. I'll go through the code, and it's okay if you're not able to understand. I'll share you the link of this question. You can check this out once more. But just to give a brief idea how to implement. See, sliding window is a very important concept. It might be difficult initially, but if you do a dry run, you will get to know it much better. So, okay, just in 2 minutes, I'll go to the code. See, we have left and right pointers, and you maintain a sum element like summation variable. What you do, what sum will contain is whatever is between left and right pointers, everything summed up will be stored in sum. So we run a while loop for right pointer. Right will run from index 0 to index n minus 1. As soon as you start the right pointer, you add the element to sum. Okay, suppose we are considering this left pointer is 0, right pointer is 0. You add the right pointer element in sum, so sum becomes 2, and you increase the right pointer. Right pointer comes at 3. And now you check the condition. So observe that in this while loop, I am increasing the right pointer every time. In every iteration, you are increasing the right pointer. But when to increase the left pointer, it will depend on the condition given in the question. And it is the general idea which we do in sliding window. You increase one of the pointer every time, but the other pointer you increase depending on the condition in the question. So you'll check if sum is greater than target, which is asked in a question. If it's greater than equals to target, our condition is satisfied, so it is possible to get a answer. One of the possible answer we can get from here. So you will do minimum length is minimum of the minimum length which we have, and right minus left. What is right minus left? So suppose left pointer is at 2, right pointer is at 1. So left minus right is, it was 0, 1 and 2. So length is 2. Right minus left. Why is it 2? Why is it not 3? Because we are not considering it's like if left was at 2, right was at 1, but length is not 3, it is 2. Why? Because we increase the right pointer here. So when the summation was of these 3, the sum was 2 plus 3. Our right pointer was at 1, but actually sum is of 2 and 3 only. That's why when you do right minus left, the length is 2. 2, which is summation of 2 and 3. Other thing you can do is, instead of increasing right here, you can increase right somewhere at the end. Then you'll have to write as right minus left plus 1. Okay, it's implementation based, but if you just focus on the idea, that is whatever is in between those pointers, you are summing it up and you're maintaining the length. Since question wants you to get the minimum length, so you every time you're taking minimum of the current answer you have and the possible answer you can get right now. After you take the sum, like after you take the minimum length, you decrease the sum. Whatever was at your left pointer, you subtract from your sum vector, I mean sum variable, and do left plus plus. So suppose this was our considered answer. So after you take the length, you remove the 3. The left pointer element you remove from summation. So your window becomes this much. In next iteration, you will increase your window. You will count this 3 in. Based on the conditions, you will remove this element. Sliding means you will remove this one. So you will consider this one in the next time. I hope you are getting the idea. Don't focus much on the code, but idea is this only. You might feel that it is difficult to implement, but I just wanted to show you the code that it's not difficult. It's just some logical thinking is required. So whatever is in between those pointers, that is what we call as the window. And left pointer increases based on the conditions, like here. Right pointer increases generally every time. Changes on the question also, depends. Finally, what you do, you check if your minimum length is not what you specified initially. See, if minimum length is less than whatever you initialized, it means minimum length changed somewhere in between. That means you have possible answer. Otherwise, you'll have to return 0. That means nowhere you find any suitable sliding window, which is in this case. Your answer was int max. If it's less than int max, you get the answer. If it is equal to int max now also, it means you could not find any answer till now, so you are returning 0. So you wrote this just to handle a test case, which is example 3. So this is what I wanted to explain. If you have any doubt, please ask.
Can you explain the time complexity for that? Is it O of n
Okay.
square?
No, see, the brute force method might go of n square of O of n cube, but you observe here, you are running this loop, and in this loop, you are increasing the right pointer every time. So that means this will run at max of n times, right? And within this, what you are doing, you are checking condition of sum, and within this we are running left plus plus. So every time when you are running, you're increasing right pointer, right plus plus you're doing, and left pointer you're doing based on the summation. So the outer will be of n times, the internal will you can't specifically give how much internal will run, but it is sure that left pointer will never cross whatever the right pointer was. If right pointer was at 4, left pointer is surely it won't cross 4. It will be somewhere behind only. So O of n comes kind of amortized. I'm also not exactly sure how should we calculate this, but if you just check this out, like we have left and right, then you have left and right like this, left and right like this. So it's kind of the both pointers are kind of sweeping the complete space, and at none of the time they are crossing each other. Left is always less than or equals to right. So that means if we focus just on the movement of right, right is increasing, right is happening of n times. So outer loop is row of n times, and it is you can consider it as a constant O of 1, or it won't be O of n for sure. So hence it overall becomes O of n only. Constant might be a bit high, but it is not O of n square. Is it okay?
Yes, thank you.
Okay. So always remember that whenever something sub-array related question is asked, think about sliding window. Is it possible to apply? So I think that's it from my end. I had a concept of quick sort. I think Soham would like to take it, or based on time, we'll see. Soham, that's it from my end. Thank you.
Yeah, I think let's leave quick sort for today. The time is nearly up, so and it'll take time for quick sort. Let's say.
Yeah, right.
Okay, so yeah, that's it for today.
I would like to give a roadmap for you guys, like
Okay.
and the topics we have covered.
Yeah, sure.
So, guys, these are the overall patterns that we have come up with. So, uh, let's start with array. So, we completed the basic definition. So, we have completed one of the data structures. And in the session itself, in the previous session, let's look at what problems we have solved. So, first problem that we have solved is subarrays with zero sum. So, here you can see we have used two important concepts for optimization. So we have used hashing via an ordered map, and dynamic programming in form of prefix sums. So it's not really that you have like completely seen a good dynamic programming question, but yeah, you could take that, okay, yes, you have solved some kind of dynamic programming question. So these two concepts were taught in the first question, and yeah, you could start solving some hashing questions and dynamic programming questions, which require arrays. So you could start practicing these questions. And in the second question, we have discussed this question, minimize the heights too, and here we dive into the approaches. So this problem was a greedy problem. So you could just find there are a lot of sources over the internet, and over the YouTube you will find a lot of videos explaining this approach. So you could start practicing greedy questions. And sliding window was covered in today's session. Two pointers was covered in today's session. Divide and conquer. So there are two algorithms. So famous algorithms like merge sort is there. That was covered in today's session. Then quick sort is there. And binary search if you just want to put into that. And there are some other topics which I think would be covered separately. And the future plan is like these topics would be covered. And regarding the algorithms portion, okay, so the fourth problem, okay, the third problem was like divide and conquer. So the fourth problem was, you required some mathematical knowledge. So it comes under algorithms and maths. So like, so what I'm trying to say is you could just look at which is the topic that you are finding difficulty with, and you could start practicing that portion. So like approaches require a lot of practice, so you cannot escape from here. Data structures, you require to learn these data structure, and so optimization is okay. These are just tools for solving problems. And algorithms and maths are something that you develop well. These are like uh, problem solving skills, kind of that. So, guys, you could identify which topic you want to like have a good hold of. You could start by doing that. And regarding the approaches, like this is kind of a lot asked in the interviews and coding round. So uh, you could start practicing these portions. So, and also in case if there is a CP sessions on these topics, I'll highly recommend you to join those sessions as well, because the more you practice, the more you will get better in approaches. And Soham, would you like to add something?
Yeah, I would just add one thing. Do follow the series. We have a lot to offer to you guys, and do maintain consistency and practice. Practice is the key. And yeah, if you want something more out of the series, I would suggest you to join the CP series, because we'll be discussing in details a lot of problem, actually a lot of implementation based problems based on the concepts that you learned on these series. So yeah, it would always be helpful. And yeah, regarding any queries or any questions, you are free to follow up on Discord. I think we'll be releasing a kind of problem sheet which you can solve after like this very two sessions that we have taken. This would the concepts revolving around these two sessions would be like supplemented with a sheet, a problem sheet, which you can solve for a better problem solving approach. So yeah, do continue the series and do follow it up, practice and follow up on Discord. That's it from my side.
Yeah.
Yeah, so if it's okay, then I think we can call it a day. Yeah, any queries, guys? Anything you'd like to ask? Okay, then I'm closing the meet. See you soon. Goodbye.